Hey kids, welcome back to Algebra 2. Today's lesson is 6.11, more with quadratic linear systems. So I really kind of felt like I didn't do enough with these when we were talking about them earlier in the unit. So I decided let's spend a little bit more time, and really just a little bit more time, just looking at a few more examples. So we introduced this concept earlier in this unit. Now we can consider what the possibilities when we graph a quadratic function and their linear function on the same set of axes. All right, so we talked about this before. How many possible solutions can we have? We can have no solutions. We can have one solution where it touches the line in one spot, or we can have two solutions. Generally, if they're asking us to solve a system, I'm assuming there's going to be at least one solution, but I hate to say never. So I like to just give you every option out there, and then we can take it from there. So exercise 1 is a typical Regents question. It says algebraically determine the values of x that satisfies the system of equations below. So this is really not a full system because if we're just determining the values of x, we're not finding the points. Because I'm going to remind you that when we have 2 points on here, that means we're going to have one xy, and we're going to have a second xy. But all they're asking us to do is solve for the x's, so that's the quadratic end of it. So this would be a simple, probably 2-point question. And in order to solve something algebraically, as it says, now we can put this in our calculator and get the answers. So you can either check it or you can start with that. And hopefully you remember how to do that because you'd just be graphing them and then look for the intersection point. So you go to analyze, right? You go to menu, then to analyze, and then to intersection. And then draw your line and then hit enter and slide it over so it shades and it shows those intersection points. If you need a little bit of a reminder how to do that, ask me in class and I'll make sure I pull up the calculator and show you again how to do that. But once again, this is telling us to do it algebraically, so that can help us check it, but it's not going to help us get full credit for this. So full credit means that I'm going to take this a negative 2x squared plus 3x plus 1, and I'm going to set it equal to negative 2x plus 1 because they're both y equals. And then I'm going to bring over, if that's okay, I'm going to do it in one step, plus 2x minus 1, because as long as I do it to one side, I can do it to the other side. So this is going to cancel out to give me my 0. This is going to be my negative 2x squared plus 5x. Whoops, the ones cancel out. And then we can just simply factor out our x. So we factor out our x and we get negative 2x plus 5 is equal to 0. And we set each of them equal to 0. So x is equal to 0 and negative 2x plus 5 is equal to 0. Minus 5 from both sides. Minus 2x is equal to negative 5. Divide both sides by negative 2. So let's just bring it up here. And x equals 5/2. So here are my answers. X equals 0 and x equals 5/2. So make sure that if it's not obvious, write down over here and put it in a box so it's easy to see what your answer is. So, like I said, probably a 2-point question on the Regents exam. Not overly difficult. We don't have to go back and find the y's. And again, I will show you how to do this in your calculator to give it a quick check. So exercise 2, let's just bring it up where we can make sense of it. Consider the system below. And here we have, oh, this is interesting. We haven't talked a lot about circles, but circles have the equation of x squared plus y squared is equal to r squared. We used to have a lot of circles in Algebra 2, but over the years it has been sort of slid into pre-calculus with the other conic sections like the hyperbola and the ellipse. So, but they do still show up once in a while, but I don't want you to flip out by it. It says consider the system shown below. The two solutions of the system can be described as both imaginary, both irrational, both rational, and one rational and one irrational. So I think the easiest thing to do here probably would be to use substitution because we do have a linear equation. So I think what I would probably end up doing is taking this 2x, and again, lots of different ways to approach these. I have this linear, so if I solve this for y, because the y is by itself, I can easily use substitution. All right, so I get negative y is equal to negative 2x plus 4. Of course, divide by negative 1, which changes all my signs, so it's 2x minus 4. So there's my linear written in y equals mx plus b form. And I think what I will do with that is I will take my beautiful circle here, which is x plus 3 squared plus y squared is equal to 8. And in case, instead of that y, I'm going to put my 2x minus 4. So let's not skip steps here. So x plus 3 squared is x plus 3 times x plus 3 plus 2x minus 4 squared is 2x minus 4 times 2x minus 4 equals 8. So let's expand all this out. So I'm going to do this piece here, which becomes x squared plus 6x plus 9 plus, now I'm going to do this piece right here, and I'm just going to use FOIL and multiply it out, which gives me 4x squared minus 16x plus 16 equals 8. Okay, I'm just double checking my math as I'm looking here, letting you catch up a little bit. So 2x, so 2 times 2 is 4x squared, negative 8, and negative 8 is negative 16, and 4 times 4 is a positive 16. Okay, so I have this piece of information here. So let's do some combining of like terms. So I have x squared and 4x squared, which is 5x squared. I have positive 6x and a negative 16x, which is a negative 10x. And I have positive 9 and a positive 16, which is positive 25, is equal to 8. So I think on my next step, I would like to factor out that 5, but we have it equal to 8, and we know in order to solve this, we have to make sure we bring the 8 over. And this is going to mess up my beautiful 5s, my factors of 5s, my multiples of 5s. So you get 25 minus 8, which is 17, is equal to 0. So you could probably factor this, or maybe you look for it. Let me see one more time. What does it say as far as, it says both imaginary, both irrational, both rational. So it means more than probably we're going to have to use the quadratic formula here because it's telling me that I could have irrational roots. So x equals the opposite of b plus and minus the square root of b squared minus 4 times a times c all over 2a. So you know me, I like to do my discriminant first. So this is equal to 10 plus or minus, once you put this whole thing into your calculator, you get negative 240 over 10. So this is what I'm interested in right here. So I know because my discriminant is negative, I know that I'm going to have imaginary roots or complex roots. So what are my answer choices? Both imaginary, both irrational. Okay, so there's my answer, both imaginary. If we had gotten something with a positive number in there, we would have had to look to see if it was a perfect square. Because if it was a perfect square, the answer would be both rational. If it was not a perfect square, then it would be both irrational. And it's almost impossible in this case. Actually, it is pretty impossible to have one rational and one irrational. Because they're either both going to be rational or they're both going to be irrational roots. So 4 doesn't even make sense. And that's really it for it. Okay, so I just wanted to give you a couple little examples on different types of systems that we can be faced with. So we do have a small independent practice portion. So it's really only, what, 3 problems? So if you've been instructed to, go through and get them done. If not, I'll see you in class tomorrow. And again, if you want some help with these, or if you want to learn how to do them in the calculator, make sure you make a note to yourself and bring that back to class so I can show you how to do that. All right? So until the next time we see each other, make good choices and be safe.